In this packet, we will look at the different forms of lines. Standard form of a line is where we have the variables on one side of the equation and a constant on the other side. One nice thing about lines in standard form is that all you need to graph the line is the x-intercept and y-intercept. Slope-intercept form is shown here, y equals mx plus b, where the slope is the number in front of the variable x and the y-intercept is the point 0, b. Let's look at an example. This example is in slope-intercept form. Before we talk about the slope and y-intercept, let's recall how to make a table of x and y values. Remember that we can plug in anything we want for x, but let's do some easy values. Now that we have our table of x and y values, we can plot some of these points on the graph. Notice I'm only plotting a few of them on the graph since all I really need is a few to draw a decent line. Now let's analyze this some more. On the table we can see what the y-intercept is. Also, here it is on the graph. And even when looking at the equation, we can see that when x equals 0, y equals 1. Also, in slope-intercept form, we know that the number in front of the variable is the slope, which is change in y over change in x. Which we can actually see here on the table. Every x value that moves to the right by 1, change in x. The y value always goes down by 2, change in y. Now let's use the formula to find the slope, which we already know is -2. To do this, I'll just pick two random points from the table, then plug them into the formula. Now that I picked the points, I just plug them into the formula, and the slope better be equal to -2. Phew! It worked! Yay! Okay, so now let's do another example using the idea of knowing the slope and y-intercept. Here we have a line in slope-intercept form again. So let's label some important parts of the line. And let's use this information to graph the line, first starting with plotting the y-intercept. And since we know the slope is -3/4, we can get another point starting at the y-intercept. And done. Let's just analyze this a little more. Note that we could have made a table of x and y values also. Notice I use x values that are multiples of 4. That's because it will get rid of the fractions. Which will make it easier to evaluate the y values. And notice that even when using the table, we still have the same points on the graph. Another example. Again, this example is in slope-intercept form, y equals mx plus b. So let's label the important information. Now we can use that information to get some of the points on the graph. First plotting the y-intercepts, then using the slope 2/5 to get a couple more points, and done. Again, notice we could have made a table to get these points as well. And here I use multiples of 5 so I don't have to deal with the fractions. Smiley face. Another example. Once we recognize it's in slope-intercept form, we can label that information. Then use it to graph the line like in the previous examples. Again, like the previous examples, we could have made a table and got the same values. Just takes a little longer. Looking at this example, we notice there is no x. So let's make a table to see how this looks. Notice no matter what x is, y is always going to be 3. So plotting all the points, we see that we get a flat line, also known as horizontal. This flat line has no slope, which means the slope is equal to 0. Also, notice the y-intercept is just 0, 3.